thank you so much for coming on the show. It's great to finally meet you in person nowadays because we do it over Zoom. So, why don't you tell us a little bit about yourself and your organization and what you're passionate about?
Yeah, totally. Thanks for having me on, Chris. So, my name is Ravi, and I'm the president and founder of a company called Sutro. Sutro basically is what I like to call
Named after the baths in San Francisco?
named after the bats in San Francisco, correct? Um, Sutro is what I like to call a floating laboratory. So we
Nice.
basically remotely measure water chemistry. Think about pH, chlorine, alkalinity, any sort of parameters that tell you what the consistency of the water is. Because if we know what the consistency of the water is, then we can better treat the water.
Mm.
So that's kind of long and short what Sutro is. We're currently in the swimming pool market. So if you have a hot tub, a jacuzzi, a pool in your backyard, you may have a Sutro out there in the world floating in your backyard. And our kind of larger goal, what I'm really passionate about, and the vision of Sutro is to basically build this for multiple different water industries. And that's for drinking water, for agriculture, for food and beverage. Wherever water touches an application, we want Sutro to be there.
Very cool. Very cool. So, I keep seeing these dystopian horror stories about us running out of water and water being a huge problem. Is water a huge problem, or is that just panic?
Oh my gosh, water is a huge problem.
Oh no, it really is a
Our
problem.
our freshwater sources are being depleted at a quicker rate than we can actually replenish them. So
Really?
the supply of water is definitely a problem. And because we're not really monitoring the chemicals that we're putting back into the water stream, think about fertilizers, the way that we use cleaning chemicals, that's going back into the source of water that otherwise would be clean, which means that we're even drastically having an even lesser amount of supply of clean water that we have available.
Oh
Um,
wow.
Funnily
I
enough,
had
I
no
actually,
idea. I had no idea it was that
yeah,
bad.
um, I had the actually the exact same question, and I ended up starting actually a podcast called Liquid Assets, which looks at the world of water. And in my, handful of many interviews so far, um, it's it's a it's a dire situation. However, it's not unsolvable. And so if we act in the next 10 to 15 years, maybe even sooner, some people would say, it is definitely solvable.
Really? So, okay. So you are finding, so you're looking at water quality and you're trying to determine and how do you determine that? Is it just the various chemicals that you find in the water, or how do you determine that the quality of the water?
It's actually application dependent. So the best example I like to give, right? You want chlorine inside your swimming pool water because it kills bacteria. You don't want to drink that chlorine water. So your
Right.
your drinking water is very different than your pool water. Um,
But you
you
can
don't
drink it
want
in dire emergencies, right? That's what I've been told. So especially here where we
probably
have earthquakes. Yeah.
probably not a lot of it, but you can
Yeah.
definitely if you needed a little bit of water, you definitely could. Um, and that drinking water you don't want to use for planting, grapes because
Mm.
you might need more nitrates or phosphates. And so that's why I say it's actually application specific because water is kind of like this balloon. You have these parameters inside there and you either kind of push or pull different things based on the application that you're using it for.
So do you create a different set of sensors for each application? So the pool water sensor is different from the drinking water sensor, which is different from is that right?
Correct. Yeah, they have a different assay set that can read different things. And then based off of what they read, they then give you outputs as to you need to put more of this or less of that.
And then depending on what you see, you can actually change the quality of the water, right? So you can can you actually take pool water and turn it into drinking water, or is it already too far gone?
No, so that's based off of what would be like a remediation or some sort of solution-based mechanism. So depending on the type of water that you're starting with and what you want it to get to, there's a different set of things that you need to do, whether you put in chlorine, remove chlorine, put in cyanuric acid, remove cyanuric acid. We can tell you what's wrong with the water, but based off of the various sets of solutions you may have, you can then basically take that toolbox and then fix your water to bring it to what might be drinking water ready
Oh,
or
really? So there
agriculture
are
ready.
ways of fixing water. It's not like when you put too much salt in a stew, you can't save the stew, you got to throw it out. There are
There's
ways of
ways to
fixing
usually
water.
Exactly. There's like membrane filters that can remove certain things from the water. There's chemicals you can put in the water. So think of it as kind of this yeah, it's this medium, it's this soup, and then you can basically add or subtract ingredients based off of what you want it to be at the very end.
Now, I'm assuming that if you've already got some ingredients in the water that are tough to get out, you'll get it to a certain point where it is drinkable or for the new application. But there's still elements in there that are not ideal.
Correct. There actually may be, and what we're finding now is there's actually this whole class of what we call emerging contaminants. We didn't even know how to sense them before, right? We didn't even know how to measure them. And
Mm,
so, like for example, PFAS is a big one that's coming around right now. PFAS, I'm not going to go through the chemical name, but it's basically found in Teflon, right? We can
mm.
we can see that a lot. It's used a lot in like waterproofing material like Gore-Tex. And so those chemicals get themselves in the water, and it's actually highly carcinogenic to humans when they're in big quantities. We didn't even know how to measure them. Now we know how to measure them, and we're starting to know how to actually remove them from the water. And so you're entirely correct. There's things in the water that we actually don't know, and we're in
Mm.
the midst of figuring them out, kind of in almost a real-time basis.
Well, that's kind of horrifying. Where is all this Teflon coming from? Is it's just leaching off people's pans because everything is Teflon?
Yeah, pans are like probably a very small percentage of them, but
Okay.
it's just an example that I like to use.
Hmm.
Um, this PFAS chemical is kind of a magic chemical. It's used in basically a lot of processes. And so they're found in a lot of things because they're it's just this magic material. And so yeah.
But how does it get into the water supply? I'm curious. Like
Oh,
if it, I mean, it's used in everything, but it's in the water supply now.
it's getting in there from our landfills. And so when we
Mm,
when we throw our things away, when it'll rain or when things will leach out of the landfills, it'll then obviously drip into a lake, river, or stream, find itself in the groundwater. If it's sitting in a stream, it'll then be used as, a reservoir. So yeah, that's kind of how a few ways that it's getting into the water stream.
how do you determine? It sounds like did you find sort of like an unknown element at one point, and then say, wait a minute, what is this new unknown element? We have to identify it. Oh, so there's are there still things like that in our drinking water?
Probably less of what Sutro does. So Sutro actually measures known parameters like
Right.
pH, free chlorine, alkalinity. These kind of new and emerging contaminants are an entirely new space. And so as we find places that have, high levels of cancer, let's say, for example, um, it's kind of this multi-pronged approach where the medical system will take a look and say, hey, we have a high prevalence of cancer patients here. What should we look at? They'll look at various different things. The medical system will then relay back to the universities. Universities will do research. They'll figure out that PFAS is an issue. And then it'll kind of be this call for action of, hey, we need to now figure out how to sense it and how to remove it.
Right.
So it's this kind of cyclical process that's this ongoing conversation between cities, healthcare professionals, universities, and then obviously scientists and engineers to then build the products.
Right. It's unfortunate we have to kind of back into the problem, though. We have to we find the symptoms, and then we determine, oh, the cause is this chemical, and then we detect the chemical so we can help further along. But there's no way really to know if there's something in there that we don't know about. There's no detectors that will tell you because things
We
have to be tuned.
we just don't know what we don't know exactly. And so
Right.
you're right. We start from the symptom standpoint because we just know that there's a higher prevalence of cancer, for example.
Mm. Interesting. Interesting. And then you don't do any processing at all. You just do the sensing, right?
Sutro is just a sensing company. Exactly. Yep.
Right. And then I'm assuming that some of your customers actually use it to determine what to do with the water once they've sensed what's in it.
Oh, 100%. I mean, after you finish sensing, you need to somehow fix or treat the water.
Right.
And then there's a whole spectrum of tools you can use from literally chlorine for your swimming pool. There's, oxidizers that are not chlorine now that can actually remove bacteria. There's UV and ozone, for example, that, shine like a light to kill the bacteria. Um, Based off of what tools you feel like using, we just let you know that, hey, your chlorine content or your oxidization content is low, you might want to do something to fix that. So yeah, the big next part of sense is actually dispense, right? So you have sense and dispense.
Right.
We're the kind of the first gatekeeper that tells you actually if something is wrong.
Right. And then you provide do you provide recommendations on what to do or just do the sensing?
Correct. Yeah. In the swimming pool industry, actually, we have a database of over 3,000 chemicals. all ranging from UV to ozone to different types of chlorines. And based off of your preferences as a customer, we can actually tell you, hey, put in 2 pounds of this, 3 pounds of that, put in a quarter ounce of this, and tell
Oh,
you exactly
nice. Where were you guys when I need to hire a pool guy? I tried doing it
yeah,
myself. It just failed miserably, so I had to hire a pool guy. It's nuts, but it's like it's funny. I hire a pool guy, and all he seems to do is put one chemical in, and it works perfectly every time. So I don't know what's in that amazing cocktail that the guy
yeah.
puts in.
I don't know what he's putting in. He's probably testing the water and putting in, that magic cocktail or a handful of chemicals.
Yeah, yeah, exactly right. So you're a startup. How long have you been around?
We started the company back in 2015.
Hmm.
Because we custom made our own sensor, there was a big weight to shoulder around actually making the technology. Building hardware is hard because not only are you making software, which a bunch of Silicon Valley does, but we also had
Yep.
to literally make the physical stuff.
Yep.
And so we launched in the market actually 1 month before COVID started in
Wow.
March of 2020. Had to pivot our entire strategy on marketing to the swimming pool industry and have been kind of commercially available in market since 2020.
Interesting. So what were you doing? Where were you pointing beforehand? Before you pivoted to swimming pools?
We initially had an entire B2B or business to business strategy. We were going to use pool stores and pool service technicians to distribute the product.
Hmm.
When COVID hit, obviously all the doors closed for pool stores because a lot of the nation was closed,
Yep.
and even pool guys, many times pool professionals didn't go into the backyards, right, for the first 6 months or so, and so homeowners were kind of left with doing it themselves.
Right.
And so at that point in time, just like you saw with the whole e-commerce boom, a lot of that stuff, we ended up kind of riding the tailwind of that. And we ended up pivoting to going from B2B all the way to B2C to just building an e-commerce store and selling Sutro online.
Yeah. Well, you had to because people had to stay at home, so they use their pools. So there's got to be some way to get your devices there. So that's cool. So
Exactly.
are you one of the founders?
I am one of the founders, yeah,
How
and one
did
of
you
the
like how
unusual
did you get into
inventors as
this?
well.
Like, sorry, what drove you into this? Like, what was there was some trigger that made you think, oh, we really need this product?
Yeah, so two kind of tangential threads. The first was growing up in sunny Southern California. My dad used to have a chain of pool and spa supply stores. And
Hmm.
so, I've done everything from testing people's pool water all the way to being a pool boy myself. Um, and that kind of always stayed with me, going through college, and after I graduated grad school, I was placed as an associate at a venture capital fund in India. And a lot of the companies that we funded were people who were building products for people who earned less than $2 a day.
Right.
And in India, water is a really, really big problem. And
Mm.
so kind of having this engineering background, understanding that water is a big issue, we tried making the sensor that was a sensor to help with drinking water.
Right.
Um, India has a ton of red flags from a governmental standpoint, and so it was really tough in marketing our product to India. And so I came back to the
Even though
US.
you
We
have a
pivoted.
huge, there's a huge demand for what you're doing.
Totally huge demand,
Yeah.
but it's just really, really tough from all the red tape that exists from the governmental side. And so reconnecting the dots, coming back to the US, I'm like, hey, Dad used to have a chain of pool and spa supply stores. We have a water sensor. Let's go ahead and flip the model around to sell this at a higher price, get more money in initially from more wealthier pool owners, and then build the longer tail of the business model to go to the drinking water stuff later once we've proven out that we can make a robust product. And
Yeah.
so that's kind of the two intersecting threads that got me to build Sutro.
That's like the Tesla model where, Elon first put out the really expensive roadsters, and then as time goes by, they get cheaper and cheaper and cheaper
Yeah,
because one
entirely.
funds the
Exactly.
next. That's a
Yep.
great idea. That's a fantastic idea. And so, but you're right now you're have you do you have plans to do that go back to that sensor again or
Yeah, entirely. So we were acquired by a large water sanitation company out of Canada called
hmm
Sandymark.
hmm
And they
Oh, I'm
themselves
familiar with
actually,
them. I'm originally
ah,
Canadian, so I
okay,
know those guys.
perfect. Yeah, they're one of the largest water sanitation companies in Canada. And
Yeah.
so because they have a pool and spa arm and a food and beverage arm and kind of a warewash and laundry arm, we are building out this initial vertical in pools and spas, and the goal is to basically scale it horizontally into their other industries.
Hmm.
And so by kind of virtue of getting acquired by them, we already have that roadmap in scaling horizontally into multiple different industries.
Oh, fantastic. That's cool. So were you looking for that merger, or did they just sort of call you one day and say, "Hey, these guys are good. Let's snap them up."
Kind of a little bit of both. We were in the midst of, raising our Series A, and it just, it was the right place at the right time. And I'm kind of glad that we did, because funding and, COVID coming thereafter, a lot of funding did dry up, especially for
Yeah,
hardware companies. And so it's great to see that the vision and the product and the team is still intact, and we're still alive selling this product.
fantastic. So most startups have like a moment when the founders realize, yes, this is definitely going to work. It's going to be successful. Like, when did that happen for you? Can you tell us that? Tell us about that?
I just
Or,
remember
or you're
that.
still not there yet?
No, we definitely have hit product market fit. We actually measure it rigorously every single week through kind of customer feedback. But I really realized that this was needed. Number one, after running so many water tests at my dad's pool and spa store, right?
Hmm.
If you go and stand out in front of a Leslie's or a pool store, and you'll see the number one reason that people come inside there is to get their water tested, which then becomes a reason for them to buy chemicals
Right.
at the pool store.
Yeah.
And so I kind of in my head was like, well, how do I take everything that I used to do in my dad's store, which number one is actually the water testing being the Trojan, and package it all into a robot and build an app that actually tells you to what to do and when to do it.
Hmm.
So that was kind of the first impetus of, I know this is an idea because I literally have done tens of thousands of water tests in my own life myself.
Yeah.
So that was
Yeah.
kind of
You lived it. You know there's a demand for this because you've seen it
I
firsthand.
literally was my first customer, and there are pool stores all around and they all do water tests. So I'm like, well, I should make a water tester. Um, and then,
Sounds like a no-brainer, right? But you guys, I mean, is there anybody, do you have any competitors?
yeah, there are competitors in the market, which also is other validation to the fact that we're not the only product out there. Um, the difference of why our product is better is because we actually use reagent chemistry, which is what they use in pool stores. They use the little liquids, they put little drops inside. We basically taken that and made it at micro scale.
Mm,
The other sensors out there in the market are what they call as solid state sensors. The big thing for the audience and for you to know is they end up drifting over time. So if you
mm,
have a sensor that starts to give you garbage data over time because the sensor itself is moving, you're going to get garbage data out. And so there's no
right.
real way of giving you that true feedback loop. So we have the most accurate sensor on the market.
Oh, very cool. Very cool. So you had that moment. There was that moment. So sorry, you had a moment when did you get a big order, or what was the moment that you realized this is definitely going to fly?
Yeah, so that actually happened with our pre-order campaign when we first launched the product, and after we got into TechCrunch, and like once we kind of launched that and just the orders started coming in, we were like, we really have to get to work and get to Shenzhen or China or the US and figure out how to manufacture this thing.
Right.
We initially ended up using the off-the-shelf sensors, figured out that that actually was a bad offering, and ended up refunding all of the money to the customers because we had just made a bad product decision.
Wow.
Uh, at which point in time, we then double clicked back into building the most accurate sensor in the market, which is kind of how we initially came to this idea. When we started deploying that, we actually not only got B2C customers, but actually started getting the industry looking at us saying, hey, if we have the most accurate sensor, we can do so much more by integrating into their products. And that's kind of, what we're in the process of doing now, outside of actually getting acquired and having a much larger corporation say, hey, this thing actually makes sense. We're going to acquire the company.
That's interesting. So why did you go with the inferior sensor at first? Because time crunch, or what was it?
It's easy to deploy. It's off the shelf. You just have two little wires sticking out.
Right.
It's the easy path. It's kind of the shortcut, right? If you just pull something off the shelf and wanted to put a little Wi-Fi chip and throw it in a swimming pool, it's the quickest way to get a product out there.
Right. I'm surprised but you didn't. I'm surprised you actually had the time to do that because aren't people looking at you going, hey, this thing needs to get out? I mean, but you didn't have the sensor differentiator at the time.
Exactly. So we basically deployed out the sensor that was the inferior version of the sensor, realized that it was just a completely bad product because using that track of sensor was just not going to be useful, and we were going to end up with way more problems down the line. So
Right.
we ended up backtracking one step to then rebuild the sensor from the ground up.
Right. And you were able to get that done in time because I'm assuming there was a time crunch there.
That's when we got acquired. So we were actually
Oh,
in the
okay.
midst of putting out that sensor. We had filed patents, and then we basically got picked up in the acquisition.
Oh, perfect timing then.
Yeah, exactly. So then they actually helped us commercialize and really get this product out to market.
Fantastic. This is great. So where do you see yourself going from here? So you mentioned you were going to pivot back into the water sensor for drinking water. What else what else is on the horizon for you guys?
Definitely building out an ecosystem in the swimming pool industry. Now that we have the most accurate sensor out there, it's really a game of making sure that we have distribution. We're kind of robustly marketing and delivering the product to our customers, both B2B and B2C. So we're restarting the B2B side. On the other side, we are actively working with Sandy Mark and other providers to basically begin R&D on the other sensor clusters.
Hmm.
And then kind of identifying the best next market to tackle because, as we know with startups, it's not good to spread yourself way too thin. So we need to be extremely strategic and um, need to be smart with the way that we actually pivot the next product so we're not taking over more than we can chew.
Right. So are you using any AI or ML in any of your products yet, or is that to
We're
come?
actually in the process. So step one was to actually aggregate a ton of data, which we have been in the process of doing. We have over 10 million tests under our belt now, which
Nice.
now gives us the ability to actually then layer on an AI and ML data set to do one of two things. One is actually make the sensor more accurate. Using machine learning, we can actually tweak the variables to, if there's any anomalies in the way that the sensors work, we can actually fix that and scrub it to make sure that it's fitting a trend line. The second thing we're able to do is actually begin to predict how water chemistry will change so we can better tell users what to do on the dispense side.
Mm.
So not only are we making the sensor more accurate, but we can actually predict what's going to happen to the water before it actually happens.
Oh, fantastic. That's really cool. So are you going to be looking at building devices that will actually fix the water, or are you going to stay in the sensor side of things?
Eventually, we do want to get into fixing the water, but it's going to be in collaboration with the fixing the water companies, which are
Right.
the filters and the chemical companies.
Yeah.
And so, yes, we definitely do have that vision. But it comes by building an extremely robust sensor that gives us 100% uptime on data and accuracy to then be able to actually dispense the right amount of chemicals.
Yeah, so I'm trying to figure out. So let's say it's time to think like futurists. It's year 10, 2033, 10 years from now. Are these devices basically going to be in everyone's homes or in everyone's locations and they can actually sense what's going on with the water and fix it at the same time? Or do you think that's further out?
No, entirely. So especially for the swimming pool industry, that's what we want to get to. I
Yeah.
think in the other markets, we may be, shortly there behind coming up with that. But if we were to zoom into the swimming pool industry, our goal is that Sutro is basically the brain hive that understands and fixes water chemistry. So your pool can basically run on autopilot. If
Hmm.
we can take that building block and then copy paste it into these other industries, we now have a template that we can, basically scale up into the other water industries.
So how would this work? Would you just sort of have it sitting in the pool, constantly sensing, and then it would send a note to your phone saying, "Hey, you need to would it already have the chemicals needed to fix the pool in it, or would that be you'd have to tell somebody what to do?"
Correct. No. So right now we already tell them what to do. What it
Right.
would be in 2033 is it would literally have a canister that's sitting on the side of the pool or something like that. It would measure the water chemistry, go up to the cloud, tell the kind of dispensing canister, hey, output, three little scoops of this thing and four little scoops of that. And so in real
Right.
time, it's basically fixing the water chemistry as it's noticing any discrepancy.
Oh, fantastic. And then how would you translate something like that to, say, drinking water in India? Would you be looking at that similar sort of thing there?
It would
Or
be similar. So the first thing would be R&D and making sure that we're sensing the right things, right? We might need different parameters in Indian drinking water, but the kind of loop is the same. And so we would then take that, put it into a drinking water pipe, say for example, or maybe at a well, based off of the input water chemistry of what it would need to measure. It would then make the necessary changes on what it would need to do to fix the water chemistry so we can make sure that it was clean. We probably would have redundancy and do a second sensor after the actual dispensing of the chemicals to make sure that the water actually was clean, especially because it's a drinking water application.
right. And I'm assuming you'd have to determine the chemical the chemical combination of the fixing liquid by measuring it and going, okay, this is generally what it needs to be fixed, and then just be able to continuously put those additional chemicals or or whatever into the water. But if there's a major change, you wouldn't be able to detect that. Or if there's some other chemical that's required that's not there, then you'd have to redo it or alert
Correct.
somebody to
Yeah.
change the chemicals out. Yeah.
Exactly. So like there's these emerging contaminants coming out. I can use the soup analogy. If
Mm,
you're making a soup and we know that there should be 2 tablespoons of salt inside there, the sensor that measures salt will know that we're at 1 tablespoon and you should add 1 tablespoon, right? So there's a
right.
discrepancy of one.
Yeah.
Uh, if all of a sudden you start throwing coriander or garlic salt inside there, the sensor that measures salt doesn't measure garlic. It just doesn't
Right.
know that garlic exists.
Yeah.
And so as these new contaminants do start coming out and there's other ingredients, right, that are put into the water, we would need to make a garlic sensor in this example. But that's just because we didn't know yesterday that garlic was even in the soup.
Right.
And so we can tell you that the salt is 1 tablespoon off, but we don't know that there's garlic in there. We'll make the garlic sensor once we figure out that garlic is a problem. And then we'd say, hey, you have, 2 scoops of garlic scoop salt in there. You need to actually bring that down or bring it up, depending on whatever the parameter needs to be.
And there's no
Uh,
way to change there's no way to have some, say, a universal sensor that can detect different kinds of chemical outputs and say and change via software, right? That's all hardware
we
based.
so the thing with universe, thinking about like a universal sensor is we don't know what we don't know. It's almost like a theoretical problem, right? Like
Right.
if you think about the soup, for example, we know that there's garlic and salt in there because we both put them inside.
Yeah.
If the combination of garlic and salt makes something, or if there's something in the air that we didn't even know that's coming in through the window because you've left it open, and now there's pollen from, daisies that are coming through,
Yeah.
um, it's not part of your soup's ingredient list. And so you went to the recipe website and you have salt, garlic, and pepper inside there. But if there's daisy pollen, you would have never, you don't know what you don't know, right? And so
Right.
now because you left the window open, again, that goes back to the symptom analysis. If people start sneezing, well, it's your allergies that are going off. You're not allergic to salt, you're not allergic to garlic nor pepper. It's the daisy pollen,
Right.
right? And so that goes back to there's no way of making a sensor that can measure daisy pollen, salt, garlic, and pepper. You have a salt, garlic, pepper sensor. And so when the daisy pollen comes into question, we
Right.
now know to measure it and we'll go ahead and build that sensor.
Right. But isn't it, I mean, I'm assuming it is possible at some point in the future that we would have sensors that could just detect substances that they don't, that are undetectable previously like it could detect something new, or is that sort of beyond, is that a physics issue that we can't get to?
It's not even a physics question, it's more of a philosophical question. We just don't know
Okay.
what we don't know, right? There's
Right.
there's things in this universe that we just literally don't know that
I
will
love
come up.
philosophical questions.
Yeah. And you're kind of always at the edge of that circle, right? Because
Right.
if we could measure PFAS, we would have fixed PFAS, but we didn't know PFAS was a problem until it was a problem, right?
Right.
It's this circular agreement or argument that ends up in this philosophical question of you don't know
Right.
what you don't know until you
But
know
is
it.
it, I'm guessing that there's no way for it to say, hey, there's something here, I just don't know what it is. That's not possible.
That's not possible because the increase of cancer patients when PFAS started in the water never pulled up on any of the sensors because the sensors weren't sensing it because we didn't know that PFAS existed.
Right. So the sensors need to know what they're looking for before
And
they
you
can
only
say something's here.
and
Right.
you only know until there's an increase in cancer patients, and we don't know if that's because of the PFAS in the drinking water or the asbestos in the wall or the
Right.
mold that might be there or
Right.
the food that they're eating because there's something. And so it becomes this multi-pronged problem that the hospital has to figure out. And so
Right.
it's kind of, that's kind of what I said in the beginning is we just don't know what we don't know until we know it. And when we do
Right.
know it, we can then solve for it.
Right. Right. Very cool. Wow. This is fantastic. I learned a lot today. Gotta say, this is very cool. Well, thank you so much. If somebody wants to get in touch with you, what's the best way?
Yeah, you can go to mysutro.com to see our product in the pool industry, and you can reach me at liquidassets.cc, which is my podcast on water.
Oh, fantastic. I'm going to subscribe right now. Thank you so
Awesome.
much.
Thank you. Yeah, thank
Talk to
you.
you later. Have a good one. Bye.